Everyone. This is Joel. I'm your microeconomics instructor. For some of you, you haven't seen me before, so this is your chance to kind of know who I am and see what's going on. Anywho, just the regular format. What's going to happen is once a week I'll come on. I'll hold an office hour. Some of you might or might not have noticed in Sapling, we already had a set of questions posted by students that they wanted some help with from problem sets. I also received an email from a student who had a question about some of the content. Your chance really, I prefer it done in the office hour form, but you can send me an email as well and just ask for something to be talked about in the office hour on every week. If there's a concept you're not getting from the textbooks, or if you still have some questions or there's a problem you can't solve, always feel free to talk to me. Just a general disclaimer, the problems I'm going to do, they might look different on your page because Sapling populates the questions with different numbers, but normally the names and the content's the same. So, I'm really here showing you methods of how to solve things. And then at times I'll amplify some of the concepts from the course that relate to the problem. So anyway, starting, the first question we had was really on kind of some of the graphing content, but it'll be more important in the coming weeks when we get into supply and demand, is what's the difference between a shift in a curve and movement along a curve. And we'll revisit this again in the future. And I'm sorry, my technology budget's limited. It's me and a whiteboard, sometimes a piece of paper. But it is what it is. I've tried to do things online. Nothing works as well as just drawing it out sometimes. So let's say that you have the graph of a curve. And I'm going to make this for supply and demand. So I'll put price and quantity here, and we'll call this a demand curve, okay? So we'll see this model later in this semester, but for now, this is what it looks like. It's a simple graph. And so if we want to illustrate movement along a curve, what we can say is movement along a curve is we start at point A, and we can move down the curve to point B. And this will be important because at times we'll say, imagine you have some given price P bar, and you trace that out and it goes to P, and you say, now imagine the price of something goes down, you have P lower bar. And what you're going to do is you can trace the movement along the curve from point A to point B, or from price A to price B. And we can do the same thing with quantities as well if we wanted to. Now if we move the curve, then what we're actually doing is we can just create a whole new demand curve. And we'll call that demand curve prime. And what would happen is that price P bar, we just extend out the price line and we could have a new A prime. And if we had this lower price, we could have a new lower price. And we'll call that B prime. We can still move along this curve, but shifting the curve is actually moving the curve. This is considered an increase, and a decrease would be shifting to the left in the case of a demand curve. It's because of the negative slope of the curve that we end up with an increase and a decrease. But price lines always stay as price lines, and more on that in the future. Really just wanted to illustrate really quick the idea that a movement along a curve is moving from one point to the other because of some external factor. And we can normally say this is an exogenous change, an external change. The price just goes down. We don't know why. Here we can say, look, we're able to produce more at the same price. So this is what we mean by this. So this will become a little more important as opposed to abstract the way it is right now. It's abstract because, and I believe this question arose just out of doing the questions for the graphing and producing the graphs problem set. So moving on, all the rest of the questions that I've received this semester so far have been related to the second big problem set. This is the PPF problem set. And so I'm not going to actually pull up the questions, but I'll give you some of the keywords so you can find them. And I did notice a lot of people had questions on robin big. And the robin big problem, robin big are cow and pig farmers. Potentially. And so the problem says, look, they can produce pigs or they can produce cows. And I'm just going to abbreviate pig and cow, P and C. That seems pretty straightforward. And so looking at my data here, at least for the question I pulled up, in one day, Rob can produce 10 cows or Rob can produce 20 pigs. Big can produce 9 cows or 36 pigs. So here's my data summarized. Fairly straightforward, right? So I just drew a table, Rob, Big, the pigs, and the cows. So the question goes on to say, assume that Rob and Big decide to specialize completely. So what specialization mean? Specialization really occurs in two ways. One is specialization can occur because you have an absolute advantage. Absolute advantage is the idea that you, given your resources, can produce more than the other person. So who has an absolute advantage in the production of pigs? Well, the absolute advantage goes to Big because he can do 36 pigs. If he devotes all of his time to pig production, he gets 36 pigs and 0 cows at that point. Rob, who has the absolute advantage on cow production? Well, that's going to go to Rob. So the square here is just absolute advantage, and that just means you produce more. And I'm sure a lot of you got that from the book. Now, the question could also arise, to determine who specializes, we can simplistically say, well, if we have two goods being produced in two people, the person who specializes is the person who has absolute advantage. But that's assuming both parties have separate absolute, that both items have absolute advantage in different, or sorry, both parties have absolute advantage in producing different items. So we've got a simplified problem here, which is that, well, pigs, there's only one person with absolute advantage, so we can clearly see that Big's the best one to do pigs. One person has absolute advantage in producing cows, and that's not the same person who has it in producing pigs. And so we could say, look, the specialization is Rob makes cows, Big is going to make pigs. So that's one way of handling this problem. Another way of handling it is to actually calculate the opportunity cost and to calculate what's going to be the comparative advantage. Now, in this case, in this special problem, the comparative advantage is equal to the absolute advantage, but that's not always the case. And you will see some other problems that look like that. And if you really have a question on this after you've worked on those, you can talk to me about it. So to find out comparative advantage, we look at who has the lowest opportunity cost to produce something. What that means is who gives up the least to make that item. So in this case, to make one cow for Rob, to make one cow, they're going to have to give up 2 pigs. Another way of putting it is for every 10 cows, Rob can't make 20 pigs. Put in perspective, it's a scaling problem. 1 cow equals 2 pigs. And, well, let's just backward engineer it. 10 cows equals 20 pigs given up. So plus 10 cows equals negative 20 pigs. We can do it this way. 1 cow equals how many pigs? And we can do this through just a simple, we can actually put this in perspective and just do it this way. So we say 10 over 20 equal to 1 over question mark. And we can then solve 20 over 10 equals our question mark, which equals 2. So that's one method. This is the ratio method. It's a method I kind of prefer. But on this problem, it's very clear and easy to see that 1 cow equals 2 pigs, just as we found up here. Now, in the case of Big, Big ends up finding out, let me get this down here so you can see, Big gets 9 cows equals 36 pigs. That's a ratio of 1 cow to 4 pigs. And you can use the same method I used here if you can't see that just looking at the problem. So who has the lowest? Who gives up the least amount of pigs to make a cow? Well, Rob. And so Rob has a comparative advantage in producing pigs. What does that mean? That means he's just better at producing pigs. In this case, he's absolutely better, but we can say also he's comparatively better. This lets us explain things why, let's assume, we could change the numbers. If this had been 12 and 10, then Big has the advantage, absolute advantage in producing both things. But what we're really concerned with is who's just better, who gives up the least to produce something. And we'd still end up with Rob wanting to do the cows. And we've got some problems that show that, and you can kind of look through those on the worksheet. So anyway, with this in mind and knowing what each person's going to produce, I'm going to create some space for myself on the board. And we can go in and we can answer the next question. So the next question says, assume they specialize over the course of 30 days. What are they going to produce? And the question goes, Rob's going to produce how many cows? So we say, look, Rob's going to specialize in cows. So Rob's going to do 30 days times 10 cows, which equals 300. Then we say, the next part says, and how many pigs? Well, if he only does cows, to do 10 cows, he has to give up all of his pigs. So it's going to be 30 days times 0 pigs equals 0. No pigs from him. Then we go and we say, okay, Big's going to produce how many cows? Well, over 30 days, we've said he's not producing any cows. So because he doesn't have a specialization advantage in doing that, so 0 equals 0. Then we go over 30 days times 36, how many pigs do we end up with? And that's going to be 1,080. And that's how we solved that part of the problem. So then the next part of the question is, after specialization, suppose that Rob and Big trade with each other, and Rob sends Big 213 cows. In order for Rob and Big to benefit from the trade, Big must send Rob more than how many, so let's see, Big sends 20 cows, so how many pigs is Big going to send back? So now we're looking at kind of relative prices. So here we have to go back to what we know before, which is for Rob, 1 cow equals, and this for Rob, for every cow he produces, he can't produce 2 pigs. So Rob's going to want to at least get 2 pigs for each cow because that's what he could do on his own. Big says for every 1 cow, he gives up 4 pigs. And so Big says, I don't want to pay more than this for a cow because I could at least do this, right? So I'm not going to pay you 5 pigs when I could get 4 on my own. So we know that Rob's sending over 213 cows, at least in my problem. So we know that he at least needs to get 2 times, right, 2 pigs for each of his 213 cows, which equals 426 pigs. And we know that the most Big's willing to pay is going to be 4 pigs times the 213, which is equal to 852 pigs. Okay, so that completes the Rob and Big problem, at least with the numbers I had. But you guys saw the method, so you can go through and solve it how you need to solve it. So anyway, it is what it is, because some of you have different numbers, some of you have same. I don't know. Some of the problems it does that, some it doesn't. I don't know. The next problem someone had was the class economy problem. So we have a class economy, and I'm pretty certain I know where the problem lied with this. But the class economy problem is that you have 50 workers, and each worker can produce 5 items per class period. So the first problem says, and they can produce either food or non-food items. So I'm just summarizing everything. 50 workers, 5 items, either food or non-food items. So the first problem says, how many food products can be produced in one class period if they all work for a food company? So you say, okay, we can do 50 workers times 5 food items equals 250 food items. Then the next problem says, how many non-food items? Well, now it's 50 times 5 non-food items equals 250, once again, non-food items. Now, the problem's fairly simple. It then says graph the PPF, and so we can graph it, and the axes might be different from what you had, so just make sure. But the way I did it was food, non-food. Okay, and so we say, look, when you're producing 250 food items, you can't produce any non-food items. And if you're producing 250 non-food items, you can't produce any food items. We connect the dots, and we call this the PPF. And I'm pretty certain all of you got this right, assuming you didn't have any technical problems with drawing the graph or things like that. So next up is every worker must eat 3 food products to be able to work the next class period. How many food products are needed for all 50 workers to eat? So if they have to have 3 food items, then it's going to be 50 workers times 3 food items means they need 150 food items. And the important thing to remember, and where some of you might have gone wrong, is that once that condition's in place for this particular problem, it's in place for the whole rest of the problem. So then the next one is move point A on the PPF to the point where every worker has enough food to eat and all of their production is non-food products. So what we want is a point where there's 150 food items, and we want to see where we end up. And if you do that on your graph, you'll end up with a point at 100. So you end up with 150 food items, and they're able to do 100 more items. And there's a 1-to-1 trade-off. So 150 plus 100 is 250, which is how much they can produce. Every point on this graph will equal 250 total food, non-food production. Right? So this is 250 food, 250 non-food. 150 food, 100 non-food is 250 total items. Okay? So everywhere total items equals 250. So you're going to label this point A. Then the next one says, move point B to the point where there's 100 food products and 150 non-food products. So we kind of flip it. And we label this B. Then the final problem, and this is where people probably had problems, is what will happen to the class economy if it produces at B? So if we try to produce at B, the question is really, is it feasible? But they're asking for a number, right? But hopefully what you're finding is the problem's kind of BS. It's not possible to be at that point. So then the question is, how many products can they produce in that class? Well, the idea is we know each worker needs 3 food items a day. So we take 100 food items, and we're going to divide by 30 we're going to divide by 3 food items. That's the number we need per worker. And what we find is that's equal to 33.33 workers. Okay. Now, 33.33 workers isn't possible, so we round down to 33 workers, because does it make sense to have a part of a worker? You can't. It's not even feasible. They'll die. So now we know we have 33 workers. So 33 workers, okay, times 5 is going to be equal to 165, because each of these workers can produce 5 items. So it's 33 workers times 5 items. And we know that they're producing non-food items. So we end up with 165 non-food items. Or sorry, not non-food, but total items, sorry. Because they could do food or non-food, my fault there. So this is 33 workers times 5 items, 165 total items. And what we'd find really is that if we broke it down, we know we need 100 food, so we'd only end up with 65 items. So we'd end up at some point here, which you're not asked to label, but just to help you guys learn, this isn't efficient because we're not using all of our workers to maximize resources. We could produce more resources and be better off, right? And so we know that we're better off here at A, which is possible, than to be at C or even worse, right? So that's that problem. So we've got 2 or 3 more problems that people had, but hopefully these are helpful. Once again, always feel free to ask. I don't mind doing this, and you know that's what I'm here for. I get paid the big bucks to help you guys get through the course. And you know, to the extent that I can't deliver, you know, a bunch of lectures, believe me, I've tried in the past. I don't have the technology. The videos I refer you to online, they're helpful suggestions. Use those videos. figure out which of the videos, who you like. Do you like Khan Academy? Do you like Jody from Economists Do It With Models? Do you like the MJM Foodie? Do you want to go Google things and find another person? But what I found is, you know, Delta College, I don't have a budget for technology. This is it. And you watch my videos, they're not as good. The sound quality, video quality isn't as good. I'm not capable of replicating what you can get from one of the other video people you'll find on YouTube. If you guys are willing to donate to the cause, you could buy me I already checked into it, you know, probably 300 for a camera and 500, 600 in recording equipment, and I could do really nice, high quality presentations. But you know, and then I need to pay someone to actually film it since I move around the room and stuff. But you know, maybe someday the college will get some funding or a grant or something to do something like that. So anyway, the next problem up is suppose that Ned can produce potato chips or computer chips problem. This isn't really a difficult problem. I don't expect a lot of people to have problems with it. There are 4 classes of problems, so what that means is not all of you get the same numbers. But the one that I ran with is that Ned can do computers or potato chips. And in my problem, Ned was able to do 25 computer chips or 50 potato chips. And so you're asked to graph the PPF. And this is an either or. So it's computers or potato chips. So he can do 25 or 50. Not very difficult. And then the next part is, what's the opportunity cost of computer chip production? So to produce 1 computer chip, how many potato chips does he give up? So we know that 25 computer chips is going to be equal to not producing 50 potato chips, because this is an either or. He can do this or he can do this. So if we want to factor this down, then we can say this is equal to 2.5 computer chips equals to negative 25 potato chips. And we could even go further. 1 computer chip is equal to, wow, I just did that wrong. But anyway, no, if someone want to correct me if I'm wrong, this would be, if I'm doing it this way, 2.5 would end up being 5. Not very helpful, but anyway. Or we can do 1 computer chip is equal to 2 potato chips. You give up 2 potato chips for every computer chip. So what we can then do is we can answer the question, which is the opportunity cost, and we'll normally put this in absolute value term, but the opportunity cost in this problem would be 2. Now the other way of thinking about it is, and they even give you a little hint, they say, look, we want it in terms of potato chips divided by computer chips. And if you do that, you end up with 50 over 25, which this is equal to saying 2 over 1 potato over chips, which is equal to saying 2 potato chips over computer chips. So you can even take their helpful little hint to try to solve it. But anyway, that's that problem. And then now we've got 2 more. These I'll probably do verbally, just because there's not much need to write down. So you know, what I found is you guys are probably like every other class I've had. People have a definite problem, which is fine, with the ones that say label each scenario deciding whether opportunity cost is increased or decreased. And the problem comes in is that it doesn't tell you which one of the problems is wrong normally. It just says 0 or 100 a lot of times. Now, some of them it does, some of them it doesn't. So I'll read through the scenarios and then we'll talk about why it is what it is. So Emily's deciding between her 2 favorite restaurants. One is Indian and the other is Chinese. The Indian restaurant became more expensive. So that means the opportunity cost for Chinese food has increased or decreased. So the idea is we want to know whether it costs more or less to do your second best alternative. So or in relative terms. So she's looking at it and she's saying, look, Indian foods become relatively more expensive. That means Chinese food. So if I go for Chinese food, my opportunity cost is actually less, right? I've decreased my opportunity cost. So for Chinese food, because I'm going to give up less to go buy the Chinese food, and I give up more to buy the Indian food. So Jacob has a bagel or a muffin. for breakfast. Muffins are on sale, so they cost $1 less than usual. The opportunity cost for the bagel has gone increased or decreased. So the opportunity cost is in terms of what you give up. So we assume he's getting the muffin because it's cheaper, because it's costing him more to buy the bagel now, so it's increased. Taylor has taken time off work to study since her wages has increased from $10 per hour to $15 per hour. What's happened to the cost of studying? Well, it used to be $10 an hour. It used to cost her $10 an hour to study. Now it costs her $15, so that price has gone up. It's an increase. And then the last one, Justin decided to take the bus to school instead of driving to school. The price of gasoline has just decreased. What's happening? The opportunity cost taking the bus has increased. So the last one was the crossword problem, and this could be problematic for some people just because you're not thinking in these terms. So the factor of production that includes the site of production and raw natural resources, you're looking for land. These stakeholders hire workers and use the factors of production. So this is 4 across. The first one was 2 across. What's that going to be? Firms. 5 across. These stakeholders own and sell the factors of production through the markets. This one's a little hard because you didn't have a lecture with me. And in the lecture, one of the things I like to talk about a lot in microeconomics, not a lot, I talk about for half a second, is that in Gregory Mankiw's book, and he's a popular, fairly conservative, but a popular economist with a very large selling textbook, Mankiw says that households and individuals own all of the factors of production. They own all of the resources in the economy. And then they turn around and use those resources by selling them to firms or creating their own firm to use them. So in this case, the answer we're looking for is households, because individuals, you don't have the letters for that, and it'd be too long. So down 1, and that's the one that really probably hurt people in terms of not being able to figure out from the textbook or whatnot. So going down, number 1, the factor of production, which represents durable goods used in the production of commodities. This is capital. And then down number 3, the factor of production, that's the application of human effort, knowledge, and ability. I bet a lot of you got this right. This one's labor. So that's all the questions people had for me this time. And that was actually a pretty robust set of questions. And I gotta say, that makes me happy. I mean, that's my job. I'm here to help you guys to the extent make your life easier. I do want to give a final note on homework. The homework grade is there. The homework's very lenient. The homework's there. It's there to be a challenge, and it will be difficult at times. The homework is graded by the computer very strictly, but when I do your final grade at the end of the semester, what I tend to do is 80 and above ends up being an A, 60 to 80 ends up being a B, 40 to 60 ends up being a C, and anything below 40 is a failure. The goal isn't to be perfect on the homework. The goal is to practice and learn something. So if you get stuck on a problem, you can always email me or text and say, hey, I've got a problem. Put it in the office hour form if there's enough time before it's due, so that I can help you with it, and you guys can figure it out and learn something. But it's okay to give up on the homework sometimes and just say, it's just too hard. I'm not getting it. You could give up, come back later, give up, and just take 0 points on it. You guys already noticed you have unlimited tries to get these homework problems right up to the due date. So, it behooves you to get the best grade possible. But in every homework set, in every problem set, there's probably 2 to 4 problems that are really, really difficult, especially if you don't have a lot of economics exposure and your math is weak. And so those problems are there to be difficult, and I'm not going to hold it against you. You could get quite a few of them wrong. Out of 20 questions, you could get 4 wrong and still be in an A category. The other thing is, don't make the mistake some of my former students have made, even though I always give this little mini lecture. Don't try the problem 20, 30, 40 times. If you've done it 5 or 6 times and you're not getting it and you don't feel like you're getting it, you need to ask for help. Talk to me, go to the tutoring center, do something, but don't just keep trying to blindly guess the answer. What I found in past practice is I go in and I look, and people do worse in hindsight. The more they try, the worse they get. And so it's better off to try it a few times. Most of the problems should be solvable, at least in the beginning sections, in 5-10 minutes. If you're spending 45 minutes on one question, you're not getting the answer. You're not figuring it out. It's not productive. So I really want you guys to know I'm here to be a resource for you and help you out. So, as long as you budget your time correctly, you should have plenty of time to always consult with me before the homework's due. Um, but if you're a procrastinator and you wait till the last minute, it's going to be very difficult to get some of the homeworks done perfectly, and you're going to have to give up something or take a lower score. If you have any other questions on class or the way the class is operating, just let me know. The class has three big components that I hope you saw in the syllabus. One is homework or problem sets. The second one's the reader assignments. They're just news articles and then answering questions. Those are graded very tough the first time, but then the second time we take it easy on you, because the goal is for you to revise your answers. The way to revise an answer is once you get your score in a comment from Kelvin, he's my grader, or myself, you're going to go back in and you can revise or edit your answer. You edit your answer, it's going to, and then send us well, I don't even think you need to send an email. It's going to notify us that you edited your answer. So you go in and you edit your answer, and then we can go back through and recorrect your grade. If you don't see your grade go up after doing that, and it's been a few weeks, let us know, and we'll try to get on top of that for you, or maybe I'll have you guys start emailing me. But the reader assignments, there's no reason not to get 100%. The problem sets, there's no reason not to get 100%. The way the examinations are going to work is we'll have the first exam in a few weeks on the first 2 chapters of the Microeconomics Second Language book, on the first 3 weeks of material. But we're going to have that first exam. The exams are, they're an experience, and so the way they're going to work is you'll take them the first time, and they'll be timed and fairly aggressively timed, and then I'm going to do a re-release of the same exam, and you'll have another week to get the exam done, and it'll be the exact same exam, but now you're going to have quite a bit more time to get it done. Probably not unlimited, but enough time to look up answers and to learn from your mistakes. I'm not going to tell you where you went wrong on the previous exam. What I'm going to give you the opportunity is to have more time to look up answers and study and try to figure it out and do better. So every exam in this course except the final will be taken twice. I do that for a reason. The exams are a combination of problems. So I give you a problem. Wouldn't be surprised to see one that looks like one of the problems in the worksheets that I don't grade and just let you guys work on, and then give you an answer key or tell you if you're right or wrong. But you can see problems like that on the exam, and then you have to calculate an answer or shift a curve or do something. And then you'll see some multiple choice, some true false. I used to do fill in the blanks. I'm probably moving away from that just because of the amount of time consumption with the number of students I have in grading. We haven't been able to, it becomes very difficult with 200 students to get fill in the blanks graded appropriately in a timely fashion when I do 2 exams. Or when you're doing 3 or 4 exams times 2. So, I'm actually grading 6 to 8 exams is a little difficult. If you ever notice a problem seems to be funky on the exam, it's marked wrong, but you think you got it right, let me know. Sometimes, I make mistakes. I'm a human just like you guys. So anyway, I hope you enjoyed this session. I hope you guys use me as a resource. I'm here. I've been trying to do a better job just personally in not answering emails over the weekend. So as a generality, I'm going to try not to answer emails over the weekend. I have this problem, and some of you might have noticed. I've gotten emails from some of you already this semester at 2 in the morning. If I'm awake, I'll respond. I've kind of promised my wife I'm going to try to back away from that and just answer emails 3 or 4 times a day and not do them on Saturdays and Sundays. So, email me anytime, and if it's important enough, I'll try to get back to you as quickly as possible. And as always, if it's really important, just give me a phone call. You've got my number. Also, I want to mention, don't forget, it's I think Sapling's easiest to use if you scroll down the web page as opposed to using the categories on the left-hand side of the page. So if you scroll down, you'll see I've written lots of material to help you on when things are due and the time frame we're covering items. And the other side is what was the next one? So it's easy if you use the web page, and I had one more thing in my mind, and now I'm having a brain fart. But anyway, it's easiest to use but you really need to make effective use of Sapling to make sense of it. and then I'll figure out what else I wanted to say later and send out an email or say it next week. Anyway, have a good day and have a good weekend. Talk to you later. And once again, go to Office Hours Forum if you have any questions, and you'll find your answer when I give the broadcast next week. Bye.